Dennis Delacourt, who's the Chief Science Officer at ZONTAL. We'll be talking about, you FAIRified your data, now what?
Yes, thank you. I will take over the screen share here. Okay, perfect. So first, a big thank you to Henning and the team at MIT that worked with them. It was really a nice way of setting the stage for the presentation that I want to share with you, because I'm totally aligned, maybe also partly because I was involved in 2017 when we defined those goals there on the slide, in really unlocking the untapped potential of data. And just putting data in the cloud, even if it's fair data, is just not enough. And so the title of the presentation is You Have Fair Data Now, which is a commodity. There are quite a few platforms around that claim they can create fair data, but which one of those is actually answering what you're supposed to do with fair data? What is the real benefit that you get from it? And so we want to explore this together. I have a few slides. We will also have at the end some live demonstrations. Depending on how much time we have, we can also be highly interactive here. I think that the 30 minutes will be plenty of time to explore this question together. So first, to set the stage, I'm leading at ZONTAL a team that's called Life Science Analytics, which has the goal of building life science analytics applications within the ZONTAL framework, whereby I have to say that the ZONTAL framework was really built on the technologies that come out of the Allotrope consortium, so the AFO, the ASM, and the ADF. And on top of those data formats and standards, we are building applications that really help downstream processes. And the reason why I can speak with a bit of confidence, not only about the automation of the lab IT, but also of the important applications, is that besides my role at ZONTAL, I'm also working at Brigham Young University and lead a team of data scientists there. And together we have worked on a few different projects that are relevant to pharma, be it lab automation or drug discovery, protein engineering, or digital pathology. And so I think what I have learned over the last 4 years is that without high quality data, you can't do good data science. But once you have the good data, then it becomes really fun. And so my mission at ZONTAL is really to create a platform that is able to bring the best data standards, which in my opinion is represented well by what the Allotrope consortium does, to as many customers as possible, so that they can rapidly develop new cool applications on top of this data, kind of similar to what we've seen in the last presentation. Okay, so this slide is supposed to present in a nutshell what I consider the biggest problem with the fair data buzzword. For the last 10 years, we have heard frequent sermons about how we are supposed to treat our data fairly, how we are supposed to verify data, and what else you can make out of that acronym. One of the big problems, however, is that many of the customers that I've been working with run projects in isolation between IT and business use cases. And to a certain degree, it makes sense because you say, I want to create a fair data lake or a fair data storage location, someplace where all the data is wonderfully prepared so that whenever the business has a demand, it can just connect to the database and solve all of its problems. But what we see in reality is often that these IT-driven projects end up creating something that you might want to call a fair data silo. And so while the business is still triggering calls against local file shares or instrument PCs or grabbing the data from somewhere else on one side, on the other side, you have this cloud solution that is supposedly increasing your efficiency in drug discovery, decreasing time to market, and what else the promises of fair data are supposed to be. And so what we really want to set out and help our customers to realize is that verifying data is not enough. You have to have some understanding of how the business can benefit from the data. Even if the initial use cases are not everything you're going to do in the future, it's very important to start with something that has tangible benefits. And so one suggestion that we have is define the right KPIs. So just because you have a bunch of files that are, for example, converted into an Allotrope format and stored somewhere, doesn't necessarily mean that you've created value. A good KPI might be something like, what are the number of successful requests that someone from the business or user on application queries against your data storage that actually results in a response which helps him to make a good decision. And so ZONTAL is all about using well-defined data in a fair format with the Allotrope supported structure to help people answer important questions and drive important decisions. This is why we draw such an architecture diagram, where we show that ZONTAL is not an end place in the cloud where the data ends, but it's rather a brokerage system that ensures bidirectional communication between all types of instruments that you have in the laboratory, as well as any type of downstream application. So you can see here like NMR, microscopy, HPLCs, whatever, instruments that are connected. And then up here you have master data management systems, ontologies, some request management systems, ELNs, LIMS, dashboards, or some enterprise search. All of these are connected directly with the ZONTAL platform. And inside of the ZONTAL platform, we perform all types of necessary standardizations and harmonizations. So here's the representation of the conversion of some JSON file, for example, an ASM or whatever, into an ADF model or some other format that allows us easy transformation of the data back and forth represented. And so basically the idea is that you have bidirectional communication between every data producer and data consumer in your infrastructure, and they're all directly connected with ZONTAL. So you never have to create point-to-point connections anymore. So if you want to, for example, build a dashboard, you wouldn't have to connect it to multiple device instruments and put some client in between that does conversions of data, but you can just rely on a connection to ZONTAL, feeding you the information in a format that's easily consumable and complete in its context, so it can be well represented. And by setting up an architecture like this from the beginning and defining already initial use cases where the well-harmonized data can be used, it becomes very quickly easy to get the buy-in from the business units, because they can see that the data that was before everywhere in all types of formats is now really easily accessible and visually interpretable and usable. And I'm going to show you some examples of that later. In order to get data into the state where it can be truly fair, we use the following principle here. So this slide shows you the data flow into ZONTAL, where on the left, you can see the different data sources. So you have instruments, you have databases, you have some cloud storages, and maybe some applications with APIs. All of those can produce data, and ZONTAL is able to take data from any of these data streams and convert it. So it is in this process, we go through some intermediate formats, enrich those with metadata that describe them proficiently into a storage that allows very easy access, be it through a UI or through some SQL calls against a database or some other open APIs that we have. It's very easy to get the data out of the system in the way that's most suitable, be it to the technician in the lab that loves to run things through a UI, or be it the data scientist that loves to write his SQL queries. You can get the data very rapidly in the form that you need it for downstream consumption. Now, if you get a data set, it's not enough, right? The fair data principles say if you get a piece of data, you should really understand what it's all about. And at the previous Allotrope, we already presented on the concept of self-reporting data assets that we published on a few times with a few of the people in the call here as well. Just as a recap, the concept that we developed is sort of the next step after saying data is fair. We're saying data becomes self-reporting in the moment where the descriptive information that we provide is sufficient to understand and interpret a piece of data without having subject matter expertise in that specific domain. Especially we're thinking here about data scientists that want to integrate data from multiple different experimental types. And it's very hard to wrap your mind around all the intricacies of the different experimental techniques that are happening in a normal pharma laboratory. And so we want to enable them to just rely on a certain set of metadata and descriptive information to interpret data and make the right decisions in how they use it and interpret it. And so the way we do that is in this conversion step from the instrument before it goes into the ZONTAL system, where we really align it with all types of master data. This is available. So oftentimes we look based on an experiment number into an ELN or into a LIMS and get some metadata out of there. But then there are also proprietary reference master data systems that are in place, or some public databases. At the end, we want to make sure that whatever term we pull out is well aligned and well defined. And the Allotrope Foundation Ontology has been a great place to make sure that the metadata attributes that we extract can be looked up and can be self-explanatory. But besides that ontology, we are also able to integrate against other open standards that are out there. The idea is once data is inside of the ZONTAL system, the entire life cycle can be managed. And then it's possible for you to search the data at any point in the future, or to build any application that leverages that data. The great benefit from this is you can now become dependent of two things. You can become independent of the original source system that created and managed the data. For example, an ELN that might be at the end of its life cycle and needs to be replaced. That data can now be completely captured inside of the ZONTAL system and then used in any future point of time without having to have that original infrastructure in place to view it, because ZONTAL has done a transformation. And B, ZONTAL can be used to now replace some of the expert tools that maybe only a certain subset of the scientists in an organization has access to, by some open viewers that come just as a default application within the ZONTAL framework. And so we have a few snapshots here of different viewers that we have configured. Basically, the idea is to stick with the ELN example. If I decommission an old ELN system and put a new one up, all of the old data goes through the harmonization process, is converted into an allotrope file, ends up inside of the ZONTAL system, resides there until someone searches for information in it. Because it's well annotated with metadata, you can rapidly find it, and then you can decide if you want to view it in a ZONTAL ELN viewer, experiment viewer that we have, or if you want to repopulate that file back into the new ELN that you have rolled out. And the same approach works also for other systems like LIMS, SDMS, or whatever you might have. Okay, so this is the part of the presentation that should just showcase to you that the fair data problem is really not that much of a problem anymore, because the solutions are so well known that we can just go about rolling it out, taking data from your instruments, making them, converting them, and then making them fair in that way. What really becomes interesting is, now that fair data is a commodity, how do we go further from here? And what is the real value that sits inside of this data? A lot of the ideas that I'm presenting here, they are based on thorough thought processes that came out of collaborations within the Allotrope Foundation. And I'm just listing here a set of publications that came out over the last couple of years, where we have together developed really these concepts, especially around the self-reporting data sets and the digital laboratory that leverage these allotrope standards. So if you're interested in learning more about the theory behind it, all of these articles are great resources to dig a bit deeper. But if we want to stick with the topic of the digital lab, I think this image helps a lot. It looks kind of similar to what you've seen at the beginning of the presentation. However, there's an important distinction here, and this is that this is now called a next generation SDMS. Scientific data management systems are replaced all the time. And most people want right now to make Pharma 4.0 a reality and push digital transformation forward. And while that is something that a lab might drive, it doesn't apply to the entire organization. So something that we see quite frequently is that our customers want to replace an SDMS with something that is future-proof and ready, but they also have something in place like a data lake. And so it's not a full re-ramp of the entire IT infrastructure of the enterprise, but it is a lab project. And so what we propose in these situations is to bring ZONTAL out and bring instantaneous business benefit to the researchers in the laboratory. And the way we're doing that is, of course, again, by establishing a bidirectional communication between the instruments and the planning tools like an ELN or LIMS, but then also by creating these fair data assets and pushing them up into the data lake so that any downstream processing can benefit from all of the harmonization that was done in the zontal layer. The true benefit of this bidirectional communication becomes very quickly evident to the scientists when you consider how their normal workflows look like. So for example, in an NMR workflow, you oftentimes see people starting out in the ELN, they create the experiment. After they have all of their parameters defined, they go over to an instrument PC and start working against the NMR. And oftentimes this requires the manual transcription of existing information, which is a very redundant and silly task because that information could be passed automatically, but just due to interoperability issues is typically not done that way. And then once an experimental run is finished, we oftentimes see data as raw data being transferred over into some, maybe back into the same ELN, while other data goes through a manual process into some analysis software tool where things are done with the raw data, an analysis report is written that is then again manually added to the ELN report. And so in a world without Zontal, this requires a lot of manual data wrangling, which is quite annoying. But in the moment where you have the bidirectionality enabled through the digital lab that's powered by Zontal, we are able to go directly from the ELN into the NMR, to the analysis, into the ELN, and the user never has to worry about what it means to shuffle data around. We have a few demos about this. If you're interested in seeing more about it, we're happy to share this with you. But effectively, it means that the scientist can just focus on what he's supposed to do and never has to worry about the problem of transferring data around. All of that happens automatically in the background. It's all hidden behind UIs and automatic workflows. And again, very important to remember, all of these automatisms are only possible because we do the conversion of the data into a standardized and open format that truly allows the interoperability. So while I'm saying all of this is Zontal, you have to also keep in mind that Zontal is based on Allotrope technologies and therefore benefits a lot from the effort that comes forth from our collaborations here. One nice application is, for example, this integration here, which shows how Mestre Labs MNOVA works together with Zontal. So this is a tool that is used to analyze NMR spectra. And what you can see here is that the colleagues of Mestre Lab have implemented two buttons, two greenish looking buttons. So the only problem is probably the contrast against their red style. Otherwise, these buttons are quite useful because in the moment a user clicks on the browser button, a dialog pops open that allows them to do a very powerful search against all the data that is managed by a Zontal system. So the user never knows that Zontal is just a dialog that opens. He can fill in the information, click on submit, and then retrieves the list of answers and responses and can select that data set that he was looking for. And so it's very quickly possible to integrate this Nova workflow with the existing Zontal system to search for data, to bring it out and perform expert analysis. And once the user is done with the analysis, can click on the upload button and it's automatically again pushed into the FAIR Data Hub or into the cloud. And it's managed by Zontal again until it's needed by a future researcher. So these type of integrations against expert analysis tools, they're quite easy now to be done. The open APIs that Zontal has developed make it very streamlined to go about this integration processes. And I think it was about a week of effort to make this one here work. I personally am very interested in solving data science challenges, especially when it comes to training new machine learning models. However, everyone that tries to do this spends a disproportionate amount of time with data cleaning. So when I think about the biggest roadblocks to data science, I come up with this list of 6 points here that you have to solve. And the nice thing about data that is managed within the Zontal platform is that out of the box, these 6 bullet points are being resolved. So in the moment where data went through the ingestion pipeline and becomes findable inside of the APIs, it is completely discoverable, it's well structured, it's clean data, it has been enriched with metadata, it was validated against the schemas that have been defined in the system, and it's also published data that you can now really subscribe to and use in your applications. a really nice application of that is I'm going to show you in a little bit that I'm really excited about. But first, let's take a look here at image data that Zontal manages as well. So image data is oftentimes really high resolution data, can be up to terabytes of files, which can be unwieldy, especially if you want to have some expert tool connected to a cloud storage that needs to be fed with data assets in there. How do you select which ones of these images that are sitting in an S3 bucket you're going to load into your application? So the way Zontal solves this is by building an application on top of the data that just sits in the cloud so that it's easy for a thumbnail view with functionality similar to Google Earth to zoom into these images and select the ones that you really want to analyze, select them and then download them into your application. And that's really highly efficient and liked a lot by the users inside of the microscopy communities. Another application that I'm going to show you in action a little bit is the flow cytometry. This is an experimental technique that oftentimes results in hundreds of Excel files because you deal with these microtiter plates, which are visualized here as a heat map. So this one is 96 wells. Each of these wells is a small experiment that produces a raw data file, which is being analyzed. And for each of these analyses, you typically have a results file. And all of these results files reside in some complicated folder structure. And when a customer, in this case, it's a quality control lab, wants to know if everything in the experiment went right, they have to open up hundreds of Excel sheets and copy and paste things around before they can get a visual impression if the experiment was successful or not. And so what we have built here to streamline this process is take data from a cloud dump, load it into this quality control framework and build a visualization on top of it that just gives you very quickly here an indication what is the number of specific events, the number of counts in the subpopulation, whatever it might be that was investigated in this flow cytometry experiment, and lets you browse visually through this data. And that is something that saves hours of very tedious work from the quality control people that are deploying this. Something else I find is really cool is our machine learning framework. So data science is something that we think should be a commodity because a lot of tasks are redundant. Not only the 70% that is spent on data wrangling, but also a lot of tasks with regard to selecting a machine learning network, subscribing it to a data set, how to configure the training process, making the training process scalable by using the right cloud resources, fine-tuning the model, making some assessments on when the model is converged, testing and validating it properly, and then finally taking the model and deploying it as an application that can be used for inferences. A lot of these steps can be completely reproduced every single time you want to train a machine learning model. And so after understanding that these patterns exist, it became quite obvious that within the Zontal framework, we can completely support this. And so what we have created is a zoo of pre-trained machine learning models, which a Zontal user can subscribe to, and then link those up with a data loader that allows the user to train or fine-tune this academic existing model on their own data. And as a result of that, they get inference models that are very much proprietary to them and can provide a really unique business value. A good example of that is based on a recent publication from my lab, which has shown that you can train for in silico drug discovery a machine learning model that can discriminate between small molecules that bind against a protein, so for in silico drug discovery, and those that do not bind. And so we found that you can train a very generic model that generalizes over lots of different targets with some type of accuracy. That accuracy can, however, be substantially increased if you have a few experimental data points for a target of your interest, and then you can fine-tune that model for that specific target. And so what we have shown in this work is that if we have a few data sets from a customer, then we can rapidly in the Zontal framework go in, select the academic model, select the customer data set, optimize it, and then run inferences on untested libraries of small molecules against that one target that the company is interested in. And if you're working in early lead identification, you know that these targets are kind of top secret. You don't want to share it with our people. So it's very important that you're able to train these networks inside of your own infrastructure and don't have any of this information spill out, which is easily possible in this setup. I'm currently in Switzerland. I'm typically based in Utah at a conference called BioTechX, and I came out of a presentation there about an hour ago now, where Arndt Finkelmann from Syngenta presented, and they have built out a new Fair Data Hub based on the ZONTAL platform, and I thought it might be interesting for the community to see a few pictures of his. So this slide is similar to the one that I have shown you, but then he also had a slide where he just explained the allotrope data format to the audience and gave the concrete example of how Syngenta implements this. So Arndt is not here to give the presentation to the Allotrope community, but I think it's nice to see how the ZONTAL framework actually also raises awareness of the standard and helps other people to realize that the things that you guys are doing here are really making an impact and changing the way we're doing science. Okay, so with this, I'm at my last slide, but I thought if we have a couple of minutes, I'm going to jump into the ZONTAL system and show you a short demo that kind of goes along the lines of what Henning presented earlier. So we have built out a few expert tools within the ZONTAL solution, for example, for NMR processing, for flow cytometry, and for this in silico drug discovery. And so I thought I'm going to show you for a moment how this flow cytometry works. 3 minutes will be fine. So let me get out of the presentation mode. Okay, so I have here a data set. I'm not going to show you how to find it because of the time constraints, but effectively this is a flow cytometry experiment that consists out of planning data where people planned out an experimental plate. Out of raw data, those are the FCS files collected in a flow experiment. Then FlowJo data, which is a commonly used expert tool to do the analysis on the data, and some final reports that are being created. So what ZONTAL does is it takes these 4 data streams, aggregates them together in a logical package, goes through all of these data entries, and converts them into an open format, so into the Allotrope format, which is then available for visualization, for example, in our database viewer. So this database viewer is similar to the Python package that was described earlier. It's just a way to parse through the allotrope files and see the information that's in there and also see the data that has been extracted and made available in a very responsive database. So here I can see, for example, the different flow channels that were used, then the different wells for which information, so the individual wells with the experiments and some other metadata. And while a generic database viewer is nice, it's always cool to have an expert tool on top of it. And so we have recently built this flow cytometry viewer that gives you an interactive representation of all of this data where I can just visually go in and select, for example, a well, then automatically see all the planning information that belongs to it and get an interactive graph of here the forward scatter against time. And down here, I get some of the abilities of FlowJo to do analysis on it. Can, for example, select subpopulations and then go in and show, for example, the gating, apply compensations, and enable the view of a user that did not perform himself the analysis in FlowJo to reproduce that analysis effectively, because oftentimes we find that PDF reports differ substantially between different SMEs. And so this is just one nice application of turning raw data from a variety of sources through the allotrope format into something that becomes truly understandable, queryable, to increase the trust amongst colleagues. So that was the live demo part. Just to finish up the slides here, the types of applications that we have built out are quite broad by now. We're working consistently on this. We also have some solutions for mass spec, for other chromatography techniques. And we're happy to meet with you anytime if you want to see anything else in more detail inside of our system. Overall, I just would like to say thank you to everyone that listened today and for all the great years that we had together working on the standard and implementing it together.
Great. Thank you, Dennis.